Hello and good afternoon, CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This is the CCNP route course, and this afternoon's video tutorial is going to be on Discovery Activity number 26. And this is the last of the discovery activities from the Cisco Learning Labs portion of the course. And these have been some phenomenal activities, and we're going to be focusing on OSPF authentication. We're going to be working with authentication between Ospf V2 neighbors as well as Ospf V3. So let's go ahead and jump in here. You can see that we've got the 4 routers up. So let's say show IP OSPF neighbor to see what we look like right now. We clearly have 3 neighbors. Let's see which interfaces we're running OSPF on. It should be Ethernet 00, 01, and 02. So I'll say show IP OSPF interface brief. And it's going to show us the areas for those interfaces as well. So as you can see, we've got the loopback and the Ethernet 00 interface, and those are going to be in area 0, our backbone area. And then we've got Ethernet 02 and 01. Those will both be in area 1, all under process ID 1. And you can clearly see here we're on router 1. Let me change the color, and let's shrink the font size here a little bit. And so you can see right here that we are on router 1 right now. And this is an area border router, right, or an ABR, because he has at least one interface in area 0 and 1 or more interfaces in another non-area 0 area. And that would be the Ethernet 01 and Ethernet 02 interfaces. So let's go ahead and clear the screen here. We'll jump back on to router 1, and let's see what the routing table looks like. So we'll say show IP route. All right, so there's 3 ways with OSPF version 2. There's 3 main types of authentication that can be configured between routers. And so we're going to be taking a look at all 3 of those types today. Now the key thing to remember is that we're providing authentication or control plane, OSPF control plane security by requiring authentication between the 2 routers. Now the key thing to remember here is that this is not encrypting all of the OSPF traffic. That is not what's being done here. So it's not encrypting the traffic. What it's doing is it's placing in the authentication type field, as well as there's an authentication field, it's placing in those 2 fields what type of authentication we're using. That's the authentication type field. And then it's actually placing either our clear text key when we do plain text authentication, or it's placing the signature or the Md5 hash. And so it's interesting, they say there's 3 different ways you can perform authentication with OSPF, keeping in mind that the first method is the method we're using right now, and it's actually null, or no authentication. So let's go ahead and jump in. We're going to start with clear text, or plain text, and what I'm going to do is we're going to kick off some debugs as well in order to make sure that we've got authentication set up and running. So Ethernet 00 was in area 0. Let's take a look here at the procedure real quickly to see what it wants us to do. And there's that authentication type. Okay, so we're going to go ahead and we're going to set up authentication between router 1 and router 2 on the area 1 interfaces here, and we're going to set it up as plain text. So there's 2 ways that we can do this, and I'm going to jump back and forth between the ways. So on router 1, we're going to do everything under the interface, right? So let's go into global config from privilege exec, and which interface was that again? That's Ethernet 01, Ethernet 00. All right. So I'm going to go Ethernet or interface Ethernet 01, and I'm going to say IP OSPF authentication, and we're actually going to go ahead, if I do a question mark, you can see it's either authentication or authentication key. So we're going to put the authentication key in here, and this is simply our plain text password. Now you'll notice it tells us that the password has to be or it can only be a maximum of 8 characters. So I'll put in here A, B, C, D, E, F, G, H, I, J, K, L, M, N. Now that's well more or far more than 8 characters. So when we hit enter, we're going to get a message here telling us that the password is going to be truncated to 8 characters. Well, let's see what that looks like. Do show run interface Ethernet 01. And you can see, sure enough, it truncates it down to 8 characters. So we just have A, B, C, D, E, F, G, H for the authentication key. However, you'll notice if I say do show IP OSPF neighbors, let's take a look at our dead timers. You'll notice the dead timer continues to refresh because setting the authentication key on the interface isn't changing the hello packets, right? Or the header information when we have the authentication type and the authentication field itself. It's not changing that. It's not until we issue the command IP OSPF authentication. So now let's take a look at the countdown timer, specifically between router 1 and 2. And you can see there, the very bottom one, we're on what I like to call the countdown to extinction here. You can see right here, we're now down to 22 seconds. And so if I continue to run this command, see if I can get in here, we're at 11. See, the other 2 timers are updating when they should. Or they're receiving the hello packets every 10 seconds, and they're refreshing that dead timer up to 40. And now watch what happens here. And there we go. So let me clear the screen here. So you can see we get a message because as soon as I typed in the command IP OSPF authentication, I'm changing the header, right, in the hello packets. It's going back and forth. It's communicating that information between the neighbors. So let's say do debug IP OSPF adjacency, right? And so this is a great way to see exactly what's happening. So let's take a look and see what we've got here. So every 10 seconds we're going to get one of these messages. And what do they say? Well, it says mismatch authentication type. Input packet specified type 0. We use type 1. And so these are the 3 different types I referred to. Remember, we haven't done anything over on, that's router 2. And this is router 1. So what router 1 is reporting here is that the input packet that we're receiving from router 2 is specifying null or no authentication, which is type 0. And here it says we use type 1, which is plain text authentication. Now remember, there's 3 types. And I guess it's kind of a stretch when we say there's 3 types, and the first type is no authentication at all, because that's really not a type. I guess it's considered a type, though, so make sure you're aware of that. The type 0 is null, but that's the default, right? We're not doing any authentication. Type 1 is plain text authentication. Type 2 is going to be the Md5, and we're going to get to that shortly here. So, but again, I want to make sure that you take a look at these debugs to see that it's actually telling us the story of why the adjacency is down. Mismatch authentication type. So let me clear the screen here. And what we're going to do now is we did it under the interface. So I'll say do you all. So if I say do show run interface Ethernet 01, you can see that both of the commands required we placed under the interface. And that is definitely one way to do it. So let's go over to router 2 now. We'll go from privilege exec to global config, do show run, and let's say section OSPF. So I can put both commands under the interface, but can I put both commands, or put one command under the OSPF global configuration section and one under the interface? Well, let's see. I'm going to say router OSPF 1, and we're going to say IP OSPF, or no, IP, what am I doing here? Oh, sorry, area, for the area. So I'm going to say area, it's actually 1, so area 1, authentication. Now, you'll notice I can say message digest here. However, that is Md5 authentication. We're doing plain text. Now, you'll notice it doesn't say plain text here, but take a look. it says that after I type in Area 1 Authentication, I can go ahead and hit the carriage return. And remember from the interface, what did we put under the interface? It was IP OSPF Authentication. So let me go ahead and hit enter here. Whoops. Let me go ahead and hit enter here. And let's on router 1, let's kick that debug back off. So we're going to say do debug IP OSPF adjacency. And so the debugging is on. Let's see if the message is any different than it previously was. And it should be 10 seconds. Within 10 seconds, we'll get something here as a hello packet floats. And there we go. Now, this is different, is it not? Because what is this saying? Well, it's saying the OSPF adjacency, right? I'm receiving a packet from 172.16.12.2. So we know that this is router 2. And now it doesn't say mismatched authentication type. It says mismatch authentication key. And it tells you right here that we're doing clear text. But it's a mismatched authentication key. And why is there a mismatched authentication key? Exactly, because we specified the key plain text on the interface here on router 1. So do show run, do show run interface Ethernet 01. And we used ABCDEFGH. So we don't have a key defined on router 2. So let's go ahead and define, or I shouldn't say the key, the password. Let's go ahead and define the password over here on router 2. So we can kick off the Area 1 authentication under the global OSPF router config section. Now keep in mind, if I had more than one interface in Area 1 right now, those interfaces would all be losing their adjacencies with their respective neighbors. Because when I enable it here under the global router config section, I'm turning it on for every interface in that area. So again, the two use cases are we put both commands under the interface, or one command under the area or under the OSPF global router config section, and then a single command under the interface, which we're going to do right now. And I believe it's Ethernet 00. Let me confirm that. It is Ethernet 00. So we'll come back over here to router 2. And now I'm going to put the same command that I put on the other router, IP OSPF authentication key. And so my password is simply going to be ABCDEFGH, and I'll put IJK. And you can see we get that message telling us it's going to truncate it. And then take a look at that. The adjacency comes right back up. So if I were to say do show run include authentication, there are the two commands for plain text authentication. One under the interface, one under the global OSPF router config section. That was on router 2. On router 1, when I say do show run include authentication, you can see that we've got both of these commands fall under the interface. In fact, the do show run interface Ethernet 01, and there they are, IP OSPF authentication and IP OSPF authentication key, and then we have the key. Now remember, the key is truncated to 8 characters, and so this is how you configure clear text authentication between two different routers, right, that are running OSPF. And again, we saw both ways that you can do it. You can do all of your commands under the interface, or you can do one command under the global configuration section and one command under the interface. So how else can I see if authentication is actually working? Well, let's say do show IP OSPF interface, and this was Ethernet 01, I believe. So when we take a look at this, when we look at the actual OSPF interface, take a look here. At the very bottom, simple password authentication is enabled. So if you were to see this and be asked what type encryption is being used, or I shouldn't say encryption, I apologize there, minor mistake, what type of authentication is being used, you would say it's type 1 because it's plain text. It's simple password authentication. All right. So now what we're going to do is we're going to go ahead and spice things up a bit, and we're going to set up message digest authentication, or Md5 authentication, that's going to create a hash that again is going to be included in those two fields in the OSPF header that goes out with your hello packets that has the MD5 hash in there, as well as the authentication type. So everything here is under the interface. So I'll keep it that way here on router 1. We're just going to update things. I'm going to say IP OSPF authentication. Now remember, I hit enter, or if I were to put null, that would change it back to using no authentication. But we want to use message digest. So I'm going to say IP OSPF message digest instead of just, or IP OSPF authentication message digest. Now, as you can see, it's the adjacency here out Ethernet 01. It says send with youngest key 0. And now we're getting a mismatch authentication type again. And these debugs are great because it tells us exactly what's happening. So it's a mismatch authentication type. It says input packet specified was type 1, which means we're receiving from router 2 a type 1 packet with authentication. And we know that the type 1 is plain text, and we're kind of losing control here, and then we've just lost the adjacency. However, we use type 2, which means MD5. So we're using type 2 authentication, but we're receiving type 1. However, we're not done yet. So let's take a look here. Do show run interface Ethernet 01. So we've got the authentication message digest. However, this authentication key, that's actually used with only plain text authentication. So what I'm going to say is no IP OSPF authentication key. And in fact, I'll leave it here so that we can see that when we put in the MD5 key, that it's going to override, because again, the message digest is not using that authentication key, because what we need to have in here is, and let's kill the debugs here real quick, do you all. So what we're going to say is IP OSPF, we need message digest key, and now I need a key number, and you can see we can have from 1 to 255. So I'm simply going to say, we'll just use 200. And then what kind of algorithm are we going to use? As you can see here, we're limited to MD5, and then we put in the key, and I'll just say AB, or we'll put Cisco. So we're going to use Cisco as our key. So what does our interface look like right now? Do show run interface Ethernet 01. Okay, so we've already done plain text authentication. We saw that. So now we're going to do the same thing with MD5 authentication. So we do it under the interface here. And again, this command right here, we're going to leave that command there because it's not hurting anything. Because when we declare IP OSPF authentication message digest, it is not going to look at that command. It's looking for the message digest key and the password. And the key and the password get combined, and that is what gets put into that authentication, that 64-byte field, or 64-bit field, that takes care of the authentication for us. So we're also going to see whether or not the keys must match. All right, so that takes care of router 1. So let's go ahead and say do debug IP OSPF adjacency. And we'll get those debugs back, and let's make sure that we're still seeing what we think we should see. Exactly. Input packet specified type 1. We use type 2, and we are sending the youngest key, which means the key that was initiated first, which is key 200. So now let's step over here to router 2. Now remember, on router 2, we did one of the commands under the interface, and then we did the other command under the router OSPF global config section. We're going to do the same thing again. So router OSPF 1, and let me make sure that we have, yeah, router OSPF 1. So again, that area 1 authentication, that's for plain text. If I want to do MD5 authentication, I need to say area 1 authentication. And remember, we were here before, and this is sort of like the fork in the road. If I hit enter, like I just did, I'm saying, hey, I want to do plain text authentication. However, if I tack on message digest, I'm saying I want to do MD5 authentication. So area 1 authentication message digest. So now I've changed the authentication method that's being used. Now we're using Md5. So let's come back to router 1 and let's see what it says now. So again, the messages have changed. If I stop this real quick, do you all, you can see the messages we're receiving have changed. Prior to me putting the Area 1 authentication message digest command in, what were we being told? Well, router 1 was receiving a type 1 plain text packet from router 2, but we're using type 2, which is Md5. So it was right around here, right about here, where I typed in the command over on router 2. Or I'm sorry, it would have been, where would it have been, where it's going to say, yeah, here we go. Would have been right about there. So let me actually wipe out those two. We'll get in the right spot. So it was right about here where I typed in the Area 1 authentication message digest on router 2. So now what are we receiving? Is it telling us that the input packet is type 1 and that we are using type 2? It's not. Now it's saying mismatched authentication key, no message digest key 0 on interface. And so where is it getting, or who is it receiving this message digest key 0 from? So by default we're sending key 0, but there is, on router 1, there is no key 0. We're using key 200. In fact, we haven't even identified the password on the other side. You can see here, no message digest key 0 on the interface. Right? So let's rectify this. Let's go back over to router 2. And here we are on router 2. We're going to have to go into the interface again. So Ethernet 00, do show run interface Ethernet 00. And what do we see? We've got, here is our previous command that had that ABCDEFGH. We're going to leave that on there, right? Because it's not going to break anything. Now, in the real world, you definitely want to clean that up. If somebody came behind you, you don't want to make it more confusing for them than it might already be if OSPF is not their strong suit. However, here, we want to leave it up to show that even with that there, it's still going to be looking for the IP OSPF message digest key entry. So we're going to put the wrong key in here. Are you ready? So we're going to say IP OSPF message digest key. I'm going to put 201. So let's see, do the key numbers have to match? So we put in that command. Let's go back over here to router 1. And now let's see what kind of debug we get with the key numbers mismatch. So router 1 is 200. Router 2 is 201. And actually, let me get the debug back on. IP OSPF adjacency. And so let's take a look at this and see what happens. So there we go. We don't have, and so what this message is saying, the second part of this message, no message digest key 201 on the interface, what that means is on router 1's Ethernet 01 interface, I don't have a key 201 that I can use to accept the key 201 that I'm receiving. So the key numbers must match, as well as the passwords. So let's resolve this. We'll come back over here and we're just going to say no, and then I'm going to change this to 200. So we remove the command. Now we matched it. Do show run interface Ethernet 00, and take a look at how quickly the adjacency came back up there. And so now the adjacency has been reestablished, right? Because we did it, or we put in the correct key. So now the keys match as well as the passwords. And so now let's talk about key overlap very briefly. And this is one of the nice things about being able to use the keys. Now, with newer versions of OSPF, you can actually define a key chain. Do show version, let me see. So 15.2. I'm not sure if it works on, I think it's 15.4. Where you can do the key chains. I have to double check that. But let's take a look at doing overlapping keys and what that looks like. So on my interface here, when I say do show run interface Ethernet 00, you can see that I've got this key 200. Well, what if I define another key? What's going to happen if I say IP OSPF message digest key and let's say 300? Md5, and we'll use a password of Juniper. Whoops. Let's see if it's going to let us do this. I'm sorry, it only goes to 255. So we'll say 250 and Juniper. And I forgot my Md5 in there. All right, now we should be good to go. So what if I say do show run interface Ethernet 00? So you can see we've got 2 keys. Now back over on router 1, what is router 1 reporting? Is he getting both keys? So you can see I'm sending my youngest key, which is 200. That means the first key that was sent. And now it's giving me this error message telling me mismatch authentication key. However, the adjacency is up, is it not? Do show IP OSPF neighbors. Router 2, the adjacency is up. It's not going down, right? And that's because key 200 is doing exactly what it's supposed to do. We haven't removed key 200 yet. So let's go ahead and say do show run interface Ethernet 01. And let's get into interface Ethernet 01. We're going to say IP OSPF, not authentication, sorry about that, message digest key, and we're going to use 250 Md5, and I'm going to say Juniper. So without taking the adjacency between the routers down, I've added new keys in. So let's say maybe somebody figured out what your key was. Now you can see it says sending the youngest key. And youngest means the most recently configured key. Because remember, we configured 250 after we configured 200. So what key is now being used to perform the authentication between these OSPF neighbors? Exactly, it's key 250. Did we see anything over here on router 2? Probably not. So the adjacency is up, it never went down. So now if I wanted to, I could say no IP OSPF, message digest key 200, Md5 Cisco. Now is that going to break anything? Do show IP OSPF neighbors. Is my countdown timer still good? No, we're still good. And why is it okay for me to remove key 200? Exactly, because it's no longer the youngest key. So we're going to send, by default, the youngest key. So no IP OSPF, message digest key, 200 Md5, Cisco. And you'll notice that it hasn't affected the adjacency at all. So this is a very nice way, if you think your key is compromised for whatever reason, or if you're just routinely rotating your OSPF key, you can simply go in, add a new key with a new key number, put it on both sides, and as we can clearly see here, this was seamless, right? I mean, this was no impact to the environment at all. The adjacency never went down, and we auto-magically start sending the youngest key. Okay, so now we've done it under, let me check here, router 1 and router 3. So it looks like it wants us to configure. Yeah, I guess it wants us to do it between all routers, and so we'll go ahead and do that. So we'll do it between router 1 and router 3, and let me get the interface on router 1, Ethernet 02. So again, very straightforward. I'll say interface Ethernet 02. We'll do it under the interface on router 1. So IP OSPF, and then what do we need? Message digest key. We'll put the key in first, and we'll just say key 100 here. And then Md5, and then I'll use Cisco as my password. But now remember, I have to have both commands, IP OSPF authentication key, or I'm sorry, authentication message digest, so that I tell that interface we're using Md5. So now let's watch do show run, or do show IP OSPF neighbor. And you can see the 3.3.3.3 neighbor. Take a look. It's below 30. Remember, the hello interval is 10 seconds, and the dead time is 4 times the hello interval, which was 40 seconds, but now look what's happening. Router 2 and router 4, those adjacencies are staying up because they're being maintained. However, we're on the countdown to extinction here with router 3. And ultimately, it's going to take this adjacency down. And let's wait for that. There you go. Neighbor down, dead timer expired. We've got a new DR-BDR election that takes place. So now let's go ahead and cruise over to router 3. And on router 3, it's Ethernet 00. And let's get it configured over here. We'll go into global config, interface, Ethernet 00. We're going to say IP OSPF message digest key 100 MD5 Cisco, but then remember we need to say IP OSPF authentication. What kind of authentication are we using? We're using message digest. So we should see this adjacency come back up, and there it is, right? So again, do show IP OSPF interface Ethernet 00. Now what kind of authentication are we doing? It's no longer simple, it's now message digest authentication has been enabled. The youngest key, which is the most recently configured key, is 100, and that's the key that we are exchanging. If I were to go back to router 1, and remember, router 1 has 3 different adjacencies, 2 of which are now set up. If I were to say do show IP OSPF interface Ethernet 02, you can see he also says youngest key is 100, and we're kind of being overrun here by debug output, but we're going to let this go. So we did both of those for router 1 and router 3 under the interface. Let's wrap things up with router 1 and router 4. And what interface is it? Ethernet 00 and 00. All right. Excuse me. So interface Ethernet 00 on router 1, we'll keep it under the interface. IP OSPF authentication message digest. So do show IP OSPF neighbor. We're going to watch that, and we're already at 29 seconds, right? 27 seconds, 25. It's going to count down. But let's see if we can get this done before. So IP OSPF message digest key, we're going to use 5, and then MD5, and then Cisco. Can I get over to router 4 and knock this out before the adjacency goes down? We'll go into global config, router OSPF 1, IP, or actually, we'll say area 0 authentication, message digest. We'll get under the interface as quick as we can and say IP OSPF message digest key 5 MD5 Cisco. Ah, we missed it. It took me too long. I was trying to get it done. So this is one of the good things with having the overlapping keys, right, is that the adjacency stays up. So you want to remember, as soon as you type in that command, IP OS or area 0 authentication message digest, that right there changes the information being communicated, specifically the authentication type and the authentication hash that's being sent between the routers. However, we got the adjacency back up right away, right? So those are the 3 different ways you can do authentication. Again, remember, the first way is the default. It's null or no authentication. So, and that's type 0. Type 1 is when we did the plain text. And remember, you saw you can do both commands under the interface, or you can do one command under the global OSPF router config section and one under the interface. And it works either way, and we mixed and matched. So 2 neighbors that were configured differently, both under the interface and one under the interface and one under the global config section, they both formed an adjacency. So that works perfectly fine. And then we took it, and that was type 1 for the plain text. Then we did type 2 authentication, which is the MD5 hash. And again, same thing. I can do both commands under the interface, or I could do it one command under the interface and one command under the global configuration section. All right, so now we're going to be taking a look at Ospf V3 authentication. Now, the key thing to remember here with the V3 authentication is that it is not using a built-in OSPF mechanism. So in the headers, you do not have authentication type and authentication keys or signatures anymore. So authentication with Ospf V3 is natively using the functionality provided by IPv6. Remember, IPsec is built into IPv6. And so this is what Ospf V3 uses. So it has made mutually exclusive, right, or completely removed from OSPF the authentication component. The authentication component now is done with IPv6. Now, there's 2 ways we can do this. The first is with authentication header, which provides authentication but not confidentiality, right? So in other words, it's going to provide authentication or legitimacy or legitimize the routers that are sending and receiving the information, right? Confirming you are who you say you are. And that's authentication header. if it's using encapsulating security payload, or ESP, what's going to happen is you're going to get both AH, right? Or you're going to get both authentication and confidentiality, right? So we'll take a look at both ways here. So the first way we're going to do this is between, it looks like router 1 and router 2, and we're going to set up just AH, or authentication, between these two routers. Now, this is a little more difficult from the perspective that when you put in the IPsec SPI, right, which is the security parameter index, when you put in that SPI value and we define the key that we're going to use, it's got to be 40 characters long. And it has to be exactly 40 characters. It cannot be shorter than 40 characters. So, and you'll see here in a second, this is where cutting and pasting comes in extremely handy. So I'm going to say, do you all, we'll kill the debugging right now. And again, you do this under the interface. So let's go ahead and go into interface Ethernet 01. Yeah, Ethernet 01. And I'm going to say IPv, and before we do that, do show IPv6 OSPF neighbors. So you can see I've got neighbor relationships with routers 4, 3, and 2. So let's say IPv6, whoops, OSPF authentication. Now you can see, you can make the argument that there are two types of authentication that you can use with Ospf V3. Null, which is no authentication, which is the default, and that's what we're doing right now. Or we can use IPsec. Well, we definitely want to secure our setup here. So here's the security parameters index, right? This SPI value. So I'm going to say IPsec SPI, and remember we said IP OSPF authentication, right? Excuse me. So you can see the security parameter index value that we can use obviously is going to vary in size. So if I were to say 256, so I could use the value of 256 if I wanted to, or I could use, looks like it's a 32-bit value all the way up to 4.2 billion. So we'll just keep it simple here. We'll say 500, right? Now, here's where I get to pick Md5 or SHA-1. Well, I'm going to go ahead and say SHA-1 because that's a more secure choice. Now, here's where you have to put in the 40 characters for the password. So I'm just simply going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 39 characters. When I hit enter, you can see it tells me that there's an error in the caret right here in the hex key value that I entered in, right? So I'll have to put one more character in there, and that's it, right? So you can see it says the crypto ISACAMP is on because we've enabled the authentication under the interface. So if I were to say do show IPv6 OSPF neighbors, whoops, OSPF neighbors, let's take a look now. Are any of these on the countdown to extinction? Absolutely. My connection, as soon as I enter that command in, look what's happening with router 2 here. 4, 3, 2, 1, and then we're going to get a message here rather quickly that's going to tell us that the adjacency is down, right? So you can see that the adjacency has gone down. So we've done it under the interface here on router 1. And so now what we're going to do is we're going to do the same thing we did before because the same options are available to us. I can do my commands under the interface, or I can do one of the commands under the interface and then the other command under the Ospf V3 global config section. So let's go over to router 2. And on router 2 here, we're going to say do show run section Ospf V3. All right, so there's my Ospf V3 configuration section. So let's say router Ospf V3 1, and all I need to do here is area 1 authentication, and you can see here it doesn't, under the area, it doesn't even give me the option to do null because that's what we're already doing. So IPsec SPI, and we used 500 on the other side. And let's see, does it have to match? So I'm going to say 501 SHA-1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. All right. So now let's go ahead, and you can see the ISACamp is on because we've enabled IPsec here for the OSPF authentication. So if I were to say do debug IPv6 OSPF adjacency, let's see if on router 2, do we get any kind of an indication that the security parameter index is mismatched between router 1 and router 2. And we're not actually seeing anything here. And in fact, so we're doing Ospf V3. I think I need, give me 1 second here. Debug IPv6. I think it's OSPF. No, it should be OSPF. Adjacency. And let's get detail. See if we see anything. So the adjacency, if I say show IPv6 OSPF, I'm sorry, show IPv6 OSPF neighbor, you can see I have no neighbors, right? Because again, the security parameter index is mismatched. Interestingly enough, we are not seeing any messages. So let's go to interface Ethernet 0, 0. Let me double check that on router 2. Yep, Ethernet 0, 0 on router 2. And now we're going to put the correct command in. We're going to pull back that command. I'm going to add in an additional 4. Or sorry about that. Correct the command here with the right security parameter index. So you can see that the security parameter index needs to match. And did I not pull back that extra 1, or did I take an extra 1 off? And do show run interface Ethernet 0, 0. Let me double check this here. Ah, it did not. Oh, I'm sorry. I entered it globally. Router. Thought I did it under the interface. Ospf V3 1. And now let's rerun this command with. And I think I've got 2 extra 4s in there. Or is it 1 extra 4? There we go. So now we have the right, and this is good that we're seeing this, right? So you also must have the correct license, right? You need to make sure that you have the do show license, the security license, I believe. And I don't know if it shows it here. Show license? No. So I thought it was show license to see the licenses. So, but you need to make sure that you've got the crypto image, and that you've got your security license. And did the adjacency come back up? Show IPv6 OSPF neighbors. So the SPI values must match. And again, take a look. We mixed and matched. We did part of the authentication for router 1. We did the authentication only under the interface. For router 2, we did it only under the global configuration section, right? So now we're going to go ahead and do the same thing. We did it between router 1 and router 2 already. Now we're going to do it between, and give me 1 second here. I want to double check something. These H must enable. Yeah, so we have been OSPF authentication. There we go. Okay, good. So again, we're doing authentication. Right, doing authentication. I'm wondering if they're going to have us do, that's AH. So we're going to try ESP between router 1 and router 3. So now remember, this was just AH. So we were providing authentication, but no confidentiality. In other words, no encryption. So let's take a look here on router 1, and we'll do router 1 and router 4, interface Ethernet 0, 0. And so what I'm going to say here, under this interface is IPv6 OSPF, and you can see where we can do authentication. However, we can also do encryption. So encryption is ESP, and that gives us authentication built in. So again, there's really no reason not to use encryption, because not only is it providing authentication, but it's providing confidentiality, and this is encrypting the information, the OSPF information running between these two routers. So IPv6 OSPF encryption, IPsec, SPI, and we're going to use, we'll say 300 here, and use ESP encapsulation. Now, here we get to choose. We definitely want to go with AES. DES has been compromised. Triple DES is more secure, but AES is far better. And we're probably going to want to pick the biggest key. And again, this is where, when we did the authentication header, or the AH only, it was 40 characters. Here, we need a 256-bit key. So you're probably asking yourself, well, wait a second, Travis. Why is it, if it's a 256-bit key, why is it only 64 characters long? Well, remember, it's 64 hexadecimal characters. Each character is 4 bits. And so what do we get? That's why you end up with that number. If I would have chosen one, in fact, we'll go back and question mark this here, because this will be interesting to see. So had I done 192, I will bet you that it would have said that the key would need to be 32.8, 48 characters long. And if we did 128 divided by 4, how many characters will we need? I'll bet you it says 32. So the different key links we're going to use are either 64, 48, or 32. So let's go back and check that out. So let me back up here, and I'll do a question mark and say, we'll say 128 question mark, and there it is, 32 keys. If I back up and say 192 question mark, 48 keys, 48 characters in the key. And again, it's because each character is being taken as a hexadecimal character when used with the encryption string. So we're going to go with 256, right? So 64 characters. This may be a little painful here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. 1, 2, 3. So what if I'm short a character? Exactly. We get an error. So let me put that last character in there for the 64th character. Oops, and it looks like we've got a little more to go. I apologize. And so what authentication do we want to use? Because again, remember, authentication is being included as well. And as you can see, this command is quickly getting out of control. So now we need 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7, 8, 9, 10. And I think I'm starting to see why this activity stuck with just authentication header. So is that everything? There it is. So let's say do show run interface Ethernet 00. So that's what the command looks like on the interface. What if we say do show IPv6 OSPF neighbor? Are we in the countdown to extinction with router 4? We sure are, because we've dropped below 30 seconds, right? Every 10 seconds we should get a hello packet. So router 4, and there's no way I'm going to get that command entered in before the 40 seconds runs up. But let's come over to router 4 anyway, and let's set up control plane security here using the encapsulating security payload, encrypting the data. And this is by far the most secure way to protect your OSPF control plane. Do show run, and actually we'll just do this. I can do it under the area as well. So we did it under the interface over there. Let's go ahead and do it under the router Ospf V3 1. And let me make sure do show run section OSPF. Let's make sure it is Ospf V3 1. It is. Okay. So all I'm going to do is say area 0. And remember, authentication, encryption, or do not use this router to transmit data. So we're not going to do that. So we're going to use encryption, right? And here we go again, IPsec, SPI. I think I used 300. In fact, let me check that, because this is definitely not something we want to do more than one time. And where were we at? I thought we showed, there we did. Showed the interface there. So 300, yep. and we'll come back over here to router 4 because we need to put in encapsulating security payload. I'm going to use AES. We're going to use 256 bits, and all of these parameters need to match. If any of these parameters do not match, we are not going to have the adjacency successfully form. All right, so here we go, 64 characters. I'll do this as fast as I can. All right, and now we have to put in the authentication type that we want to use. All right, and there we go. So let's see. Does the adjacency come back up? We've got the crypto, or the ISACamp has been turned on, and take a look at that. The adjacency comes back up. So let's confirm do show IPv6 OSPF neighbor. And there it is. Router 4 has its adjacency with router 1. Now, if I were to say show crypto IPsec SA and under the specific interface Ethernet 00, you can see that it's going to show us the information with respect to the security association between router 4 and router 1. And again, this command will work even if you're doing the authentication header only, or the AH only. However, remember, the most secure way to lock down your control plane is going to be using the encrypted method here with Ospf V3. You can see we've got our transform set, right? And where do we have? Let's go back up to the top here and see what we've got. So here you go. It shows the security parameter index, right? It's under Ospf V3. We're using SPI 300. It's going to show us our link local address. And so this is really the policy name that gets created for you when you run this command. Now, if you've done any IPsec tunnels, point-to-point tunnels, you'll recognize this output, but you're probably thinking to yourself, hey, wait a minute, we never created a policy, right? And there are many more steps involved, and you're absolutely right. It's all done auto-magically for us. And look at the remote crypto endpoint. Shows the multicast address for the all SPF routers here. The local crypto endpoint is our link local address. And what other information are we looking at in here? The most important piece of information is right here. Packets encapsulated, encrypted, and packets digested, right? So this is showing us that we're receiving information and we're encrypting information, right? And we are also able to decrypt the information. Let me scoot down here a little further and see what else we've got. Yeah, not much else other than the status is active, right? It shows us the crypto map was automatically applied to Ethernet 0, right? So it's not using an SVTI. It looks like it's auto-magically doing a crypto map for us and applying that crypto map in the background, sort of behind the scenes. So again, this is definitely the most secure way to do it. Show run interface Ethernet 00, or I'm sorry, we did this under the show run section Ospf V3. And so there we go, right? We've got this huge encryption that's taking place. And that is definitely the way that you want to configure your control plane security between Ospf V3 partners, especially if you're using, like I said, if you're using Ospf V3. All right, well, this wraps up the authentication section on this activity on OSPF, and we've done a ton with authentication and locking the control plane down. We looked at OSPF version 2 and the 3 different types of authentication that you can do. Null, which is type 0, plain text, which is type 1, Md5, which is type 3. And we looked at all of those. We saw that we can do it under the interface all by itself, or we can do it under the global config section and a single command under the interface. Then we took a look at Ospf V3 and really did a deep dive here. We set up the authentication header method of securing the control plane, seeing that we only have to put a single command. And that command can be under the interface if we want to have very tight control over which interfaces are doing what. and we could do it under the area, under the global Ospf V3 config section. However, what this means is every interface in this area running OSPF is now running this encryption method as its security, right? So you would have to make sure that any neighbors in area 0 were also properly configured, or else you're going to run into issues. Now, the final thing is, remember that the interface configuration overrides the global OSPF configuration. And that's in both cases. It's in this Ospf V3 as well as Ospf V2. All right, well, hopefully this has cleared up OSPF authentication for you and locking down your control plane when using the Open Shortest Path First protocol. All right, guys, happy Thanksgiving, and I will see you all on Monday.